Okay, so let us start. Today we are going to talk about the autonomous systems part. In that, the first part is sensors with autonomous vehicles. So, autonomous systems are the systems that works based on the sensor and takes the decision based on the machine learning algorithms that you have provided. So, the today's talk will be focused on autonomous vehicles, which is a kind of autonomous system, one of the kinds, and then in that a specific subpart where the sensors are discussed used in autonomous vehicles. So, if you see any car on the road, few of the sensors are already there, even if it is a manually driven car, and few of the sensors are completely missing. So, we start with a radar sensor. Now, radar sensor is typically used to get the data for the surroundings, and then there is a LiDAR sensor. So, what is the difference between radar and LiDAR? Radar will work on radio frequencies, that is EM waves, and LiDAR will work on light source, that is laser. Then there are cameras in front, cameras in back, and then there are cameras on top. So basically 360-degree view from the camera is captured. Then there are additional LiDAR units which are one-dimensional LiDAR. Typically LiDARs are two-dimensional. They scan 360 degree, but then there are some additional LiDARs which are 1D, and then there are onboard computers. Now these onboard computers are very high processing power computers. They generally include 256 core GPUs, and then they can do parallel execution and run the ML algorithms in real time within milliseconds. Now, projected autonomous vehicle registration, it started, if you see in 2021, it's 0.1% of the total number of vehicles, which is a huge number. Still, it is very less. By 2024, it is 0.049. That is very small amount of total percentage, 0.5% you can say. And it is expected to grow slowly till 2028, and then by 2030 it can reach up to 12% of the total vehicles. Again, these are uh, some numbers which are predicted, and it may not turn true provided the currently autonomous vehicles are designed with petrol vehicles, and then there are some autonomous EVs also. So there is a war going on between petrol vehicles and electric vehicles. People want to protect their money, and that's why petrol vehicles are preferred. But slowly, because of the pollution issue, they will be discouraged, and we will switch to EVs. So a natural partner for any autonomous vehicle is EV because it already has a battery pack, and autonomous vehicle or all the competitions require a huge amount of computing and battery power. So running them on a fuel will further reduce the overall mileage of your car. Typically, you are getting now 7 to 15 kilometers per liter, at least in Indian road scenarios, and then it will further reduce if you try to go in autonomous car. So practically not feasible to implement any autonomous vehicle on road, and that's why we need to switch to EV, and then it will become a natural partner of any autonomous vehicle. Now, in this particular talk, we are going to talk about four autonomous vehicle sensors which are used in self-driving car. The first of them being camera sensor, and we will learn why this particular sensor is important. In your exams, you might receive a question like explain the use of camera sensor in autonomous system, or it could be a specific application based on the camera sensor. Then you have radar sensors. Now, typically these radar sensors cost in the range of 1 lakh rupees to 5 lakh rupees, and that's why the overall cost of autonomous vehicle will be always on a higher side, typically three times the original cost of a vehicle. Currently in India, the cost starts roughly around 5 lakh rupees, and it can go up to 1 CR also. Some of the cars are 2.3 or 3 CR also. But always remember that this particular car cannot be starting at low price. Minimum costing of any autonomous car will start at roughly around 12 lakh rupees, and it will go higher as we increase the number of sensors. Then comes the cheaper sensor, which we call a LiDAR sensor. Now, LiDAR prices are varying in the range of 5,000 rupees to up to 5 lakh also, depending upon whether you are taking a moving LiDAR or a static straight LiDAR. And then there are ultrasound sensors, which are as a backup for all the light sensors, because it might happen that light sensors might fail if there is a glass in front of a car or a mirror in front of a car or any reflective surface or absorbing surface, that is transparent surface. Your LiDAR sensor fails. So at that time we need a backup plan, and that backup plan is nothing but an ultrasound sensor. Now, how does car see? So you need a camera in front. Now you might have seen the dash cams which are installed in the cars. This dash cam starts with a price range of 3,500 and can go up to 9,000, 10,000. And then there are dual dash cams which are for the front and the back of the car, and they roughly charge from 6,000 up to 21,000. These dash cams are nothing but simple CCTVs for the car, which are placed inside the car and monitoring the outside. So, in case of an accident, these dash cams can be used as a proof that whose mistake was that, and then insurance company can give the claim accordingly. Then also in courts, sometimes if there is any dispute, these dash cams are used. With autonomous systems, we don't need these dash cams because these systems already are pre-built with the cameras, and these cameras typically capture all the surrounding 360-degree all the time. So you are monitoring every aspect, every side of the car, which is not the case with the dash cams. So these cameras are basically used to detect the objects in front of the car. So here you can see that there are people walking, and these people are detected using a machine vision approach. This particular approach of person detection is called YOLO, which means you look only once. You also have to understand that these people are walking on a zebra crossing, so they are legally correct, and you have to stop if people are walking on a zebra crossing, and that rule is pretty strictly followed. So that's why, with the main advantage of autonomous cars, that they will not break the rules like humans, and they will never be tempted to break any rule because it's all rule based. So if your camera is seeing a zebra crossing and people are walking on it, it will stop. Now coming to an camera sensor, the current sensor NVIDIA Drive is a partner with uh, Seconics company, and this is a 360-degree camera sensor. This camera relies on autonomous vehicle placement with front, rear, left, and back. Now, why four cameras are placed? Since they are getting the information like a fish eye, they will be giving more information, some overlapping information, and overall, the feeds from four camera are forming a complete 360-degree view or environment around the uh, feed. Then there are some cameras which can capture up to 120 degrees. So if you see 120 into 3 will do the job, but then we consider always overlapping fields so that the edge to edge matching can be done to make the complete 360-degree environment. Again, remember this 120 degree is a solid angle and not a 2D angle. So it's like a cone. अब बर्थडे में जो पहनते हो सर के ऊपर उस तरह से एक एंगल होता है 120 डिग्री, and that's why it can capture a lot of information. Now, how deep learning is used in autonomous vehicles? So typically we need a trained model. So आपने देखा होगा, आप कोई वेबसाइट जब लॉग इन करते हो, it will ask for a captcha. So what is this captcha? This captcha is nothing but it is trying to get from the human what this particular object is. And you see, most of the captchas will always ask you where is the mountain, where is the bicycle, where is the zebra crossing, where is the people, or find out the objects with bike. So we think that we are filling the captcha for the security reasons, but at the back end, it is actually training the deep learning on a larger scale by the autonomous vehicles. So remember this. And then Whenever we feel this training is sufficiently good enough, then they deploy it. The only company that trusts camera is called Tesla. Tesla does not depend on LiDAR. The owner of the Tesla says if human can drive with two eyes, then two cameras should be sufficient enough with intelligence of human to drive a car, which is kind of true, but there are other senses also which typically camera doesn't have. So these cameras comes with something called as IMU that can sense the acceleration, bumps, everything, and it can also give tilt and other senses. So typical detection using deep learning is done for the lane. So whether your car is within lane or not. Second is for the human or uh, a dog or a cat. So in Indian road scenario, when we work, we found that only human detection does not work because we have cows roaming around on the road. We have dogs, cats roaming randomly on the road. So that way we need to have more detailed detection. And then there are cars. So with the cars there are two kind of detections required. One is car which are static in nature, and the other type of cars which are dynamic in nature. Now all these cars can move. So what do we mean by a quasi static state? That is this particular state where car is resting or parked on the road and it is not going to move. So it is very important for the autonomous car to detect this quasi-static state and to classify the. I will show you some of the examples which my student did in his work later on in this talk. So that is how the car can be detected as dynamic object, but it could be quasi-static or it could be completely moving object. Now, in live video, this is the kind of detection that happens with the autonomous car. And you can see that the traffic light is detected with 0.997% confidence level. So once the traffic light is detected, then it detects whether it's green, red, blue, or in some countries it is yellow, or in some countries it takes other forms. And based on the information, it can take the directions. Now in traffic light also, it may not be always true that it is green or red. So there are some only left type of signals, only right signals, or go straight and left signals. So there are different cases where the traffic signal can take place, and we have to do a multi-class classification after detecting the object as a traffic light. So that is another problem that we faced in India a lot. Uh, then car, it is very clear that cars are not manufactured by 50 lakh car owners or car manufacturers. So definitely modifications can be there to the existing car, but overall structure remains the same. So that's why it is definitely possible to train each and every type of the car. In India only we have 978 types of vehicles. So you have to imagine that each vehicle's 100 photo if we take for the training, the overall data will be 100 into 978. So it's a huge data, and we don't want to classify them separately. I don't want to know whether it's a Maruti Suzuki or it's a Wagon or it's a Tata Nexon vehicle, but I want to know whether it's a vehicle or not. So that's why these are treated as a dynamic objects, and it doesn't matter. For me, it's car. It doesn't matter of which brand it is, and that makes my life easier because then it becomes a binary decision. Now, obviously, this information can be used to gather the other kind of information, like what companies' cars are sold mostly, what people are using on the road, and all those things. So, data analysis can be done on this particular information that we gather through the autonomous vehicle. But typically, we just focus on a binary classification for the purpose of autonomous vehicle or self-driving vehicle. Now, I think this is a video where you can see how in real time a car is seeing the data. I will just play this video for you. So you can see the confidence grid. So green is called the most confident length where the car should be always. So it tries to bring down the entire car into the grid of green. And obviously, the car will have its width. It is not a cycle, so it has to consider a set of green pixels before that it can drive. And red is the worst case where the car should not go. Blue and yellow you might have seen. So these are the low confidence regions. So kind of blue is where you can take your car, but it might have potholes or not a plain road to drive on. Here you can see some of the footpaths are marked as blue. So in India, with the bikes, people usually get on the footpath and cross the traffic. But for autonomous vehicle, that will be really tough. So we imagine that there will not be any autonomous vehicle going on to the footpath and crossing the traffic. It its major purpose is to drive through the green zone. Now, if you also see in this video that in real time, within a fraction of a second, it can capture and especially just focus when there is a turning. So if there is a turning, there will be a two path generated, and then a dynamic decision needs to be based on the path planning algorithm. So whenever there are more than one path where the car can go, immediate dynamic decision based on the path planning, that coordinate given by GPS will tell you which side to go. And not only that, the other thing is there are some one ways which needs to be pre-programmed. So car will never know whether it's a one-way road or a two-way road. It has to be pre-programmed, and then only it can drive it properly. Otherwise, once the autonomous vehicles are on the road, you have to change the concept of one way, and none of the roads will be ever be one way. All the roads will always have a bidirectional traffic. Now, this is a image how it looks like in a night vision. So this is, I think, a live feed. Now you see this is a camera output, and then you will realize why the thermal camera or night vision camera is useful in this particular scenario. So if you are driving in the night, this is how you will see the image, and on the other side, you can see how a night vision camera can see the image. So I will just play this clip also. This is an autonomous vehicle. I think there is some deer or elephant. I don't know what it is. I think it's a deer. Small dog was also there. I hope it was dog, not a fox. But so basically, this is how autonomous vehicle can be helped through the night vision camera. And it is very important to have a night vision camera to the uh, car so that it can gather the more information. This is basically a thermal camera, so heat signature from the plant and animal will be different from the other objects. So you can firstly treat or find which are the living things, and once you know the living things, you could be aware of that you don't have to hit those living things. So that should not be on the grid. Now coming to the main camera sensors, the third camera which is placed on top of the car is called 360-degree camera. Now in photography, these are also called as omni cameras. So those who are from electronics background, they might know that there are some omnidirectional antennas. So omni means it throws everything equally or in all directions. So 360-degree camera will give you a feed like this. It looks pretty weird if you see it's a circular information, but this is how we also see the information. And then our brain processes this information to get the views that we are seeing now. So actual information that you get onto your eye, it's something similar to a 360-degree camera, exactly like this. And this thing also rotates to gather all the information. Since you can't move your eyes more than 120 degree, you don't get 360-degree views. But animals like fishes, they do have a 360-degree view. So anything coming from the back, they can also sense that. Now, this particular camera is needed to ensure that no vehicle is coming from the side and trying to hit you, and also from the back. So obviously, you can put individual camera in all directions, and then why the need for 360-degree camera? Then also your top is not covered. So typically 360-degree camera can see if anything is falling from the top, which will be a rare case for the car. But since humans can see if anything is coming from the top, same provision is given to the cars also. So it can sense the rain or the snow, or if there is any storm, it can also sense that. Now, this is our typically layout camera will have. Initially, it will have camera which is numbered at one. Then you have a mirror, set of mirrors that is gathering the camera's information. So remember, whenever we say a 360-degree camera, basically it is capturing the light from multiple directions, and this light is captured using mirrors. So internally there will not be any multiple sensor. It's a single rectangular sensors on which the light is adjusted in such a way that it can gather information from different mirrors. There are some other ways of generating 360-degree images. Just take your regular camera and rotate it on a servo with 360-degree, and you can get the 360-degree image format. But that is like a stitching of the images to get the 360-degree, which will be slower, and we need a fast response. So remember, that is why we are going for this kind of camera technique. But if you want to create a virtual reality scene where 360-degree images are required, then definitely you can go for a higher resolution camera and having a more sensor camera. Then it comes another type of camera which is called a fisheye camera. Now, how this camera is different from 360-degree camera is it can see between 100 to 180 degrees. Typically, how a eye of a fish will see. Same logic. So if you see here, there is a lens which is you can assume it to be a half cut sphere, and it can gather the light from all the directions and put it onto your LCD. And the typical image gathered from a fisheye camera looks like this. So basically, it represents a equivalency of a fish and its eye, and that's why it is named as fisheye camera. Then, as I mentioned earlier, night vision camera is very important. Remember, all the cameras that you get in the market are typically UV filtered. That means you cannot see the UV light, and that's why this thermal camera needs to use a UV free filter, UV filter free camera, and these are called night vision cameras. You can also convert any of your regular cameras into night vision camera. If you open the camera and remove the filter of UV from the top of it, you'll start seeing the infrared information. And also, you will also get another information which is basically only infrared. So night vision camera do not show you a regular RGBD colors, and that's why they are very useful. So instead of blocking UV, it will only allow UV to go through. And what is the information in UV? So whenever there is a living creature, it generates a heat, and this heat is typically in the range of UV. So that's why any living person body, if you see, it will look lit up, and that means that that person is alive and still generating the heat inside its body. Now, the most popular camera in the market is called 3D stereo depth camera, and it is costing roughly between 30,000 to 50,000, and it's called Intel Real Sense. So it's a standard camera. It has a depth sensor, it has a IR projector, and a color camera. So anytime if you visit my office, I will show you this particular camera is kept in my room, and you can see how it can measure RGB camera. Along with that, it can show you the depth information precisely, and this depth is pursued by these two lenses. Typically, these two lenses are placed at a distance of an eye, so 6 centimeter, and that's why it can gather the information, 3D information. So if you try to close one eye and try to see the things, and then try to close the other eye, you will see that there is a difference between the two, and that's why the depth information is perceived only with the stereo camera. These are IR stereo cameras. Again, IR, as I mentioned, IR camera is nothing but your regular camera, but it also has the information and it can gather the information based on the IR heat emitted by the bodies. Now, what will happen if there is a car in front in the night vision camera? That's why you also need a IR projector that will throw an IR light from the depth camera, and then this light is falling onto the car surface or any non-living surface, and then that depth can be perceived. Now we move on to the second sensor. So firstly, we have seen what are the different types of cameras used in an autonomous system. And now you can write a short note on that. So roughly 10 marks question might come at different types of cameras used in the autonomous systems. Or there could be other question that what are the applications of the cameras in an autonomous system. And autonomous car can take taken as an example in that. So radar is basically people are using radar in military operations to detect the aircraft, and the weather forecasting is also done through radar, like clouds and air movements and winds. So how particularly radar is helpful for the car? Similarly, when there is low visibility or night driving, your LiDAR sensors are typically useless. If you see if your car is kept inside a glass dome, it will hit directly to the glass dome. It will never realize that there is a glass. So that's why secondary sensor was important. We have a low cost ultrasound, but then we need a very highly accurate sensor, and that's where we go for radars. So not all car companies, remember this very carefully, not all car companies are using radar in their autonomous vehicles. So it's a risky business, but definitely people can take the risk for the cost. It will save a lot of cost if you don't put the radar onto the autonomous vehicle. So on a larger side, if you are driving, it is basically a radio wave, and detecting a moving object through radio waves is also very easy because of the concept called Doppler shift. So what will happen if you transmit, let's say, frequency of F hertz onto a moving object and F hertz onto a non-moving object? So what happens due to the Doppler shift, there is a change of frequency called delta F, and this delta F will tell you the speed at which that object is moving, the direction in which that object is moving. Whereas with regular static object, that F will remain F and delta F will be zero. Delta F is the change in the frequency. So when you transmit, let's say using 100 hertz, and if you are receiving 101 hertz, definitely you can, by the magnitude, you can say how far is the object, but by the frequency change, you can say that that object is also moving. And there are a lot of machine learning problems based on the signal received from the radar. The main force is direction of arrival, so DOA that is called, and people are working with the radar signals to estimate the direction of arrival. Also, if there are two objects coming towards you, at what velocity they are coming and which direction they are coming, all these informations are a signal processing problem which are connected to this subject. Again, in machine learning part, I think sir might have explained you KNN, then there are SVM techniques and many other machine learning techniques. So in this particular case, the radar acts as a 1D signal source. For the camera, it's a 2D signal source. So remember, signal processing is at the back of this particular subject, where machine learning algorithms are getting the input in the form of signals, either 1D and 2D signals, and autonomous systems are using sensors to get this data in the form of 1D signals or 2D signals. Now, radar 77 gigahertz is the frequency which are given for the cars, and basically all the automotive radars use this particular frequency so that the logic that we are writing about delta F will be constant. So for all the cars, it made compulsory, it's kind of a standard to have a radar with this particular frequency range. And if there is any object, so there are two types of radars used in the car. One which is costlier is called the long range radar, and these long range radars typically ranges between 8 meters up to 100 meters. So you can imagine you can see the things up to 100 meters far. Definitely your eye can see that much. But using a exact destination like 1 centimeter accuracy for 100 meters is very possible through your long range radar. And then there are short or medium range radars, which are connected for the detection of blind spots. So those who are driving, they might understand the concept of blind spot. These are the spaces on the road where you can't see the other vehicle or other person. And there are always blind spot in a car. So typically when parking, you might see a lot of blind spots because you don't get the full vision from the back view or both the mirrors, and that's why you generally have a ultrasonic parking sensor which starts beeping when you are going very close to park the or hit the object. And similarly, these short or medium range radars are also used. And also there is something called as adaptive cruise control radars. So basically, for cross traffic and adaptive cruise control, your car will go on driving like a autopilot mode when you put it into a cruise mode at the fixed speed and with the fixed steering angle. So you need to have more sensors in the case if some car suddenly changes the lane and come in front of your car. If the car is in cruise mode, it will directly go and hit the car, and that's why you need a short and medium range radar sensors. And typical cost of this short or medium range radar can go up to 30K, and it is very useful sensor. So one can explore this if you are building any distance sensor. Now, what are the different monitoring or different radars that you have onto the car? First is a short range or medium range radar, which is typically used in your park assist, cross traffic alert, and the junction assist. Now, coming to the medium range radar, this is for the blind spot or blind slide detection. Then there is a driver monitoring radar for the 3D positioning or even driver alertness and awareness. So this radar is pointing inwards the car. So what happens is if your driver is feeling sleepy or not sitting on a chair, or so we think that it is detecting by the weight of the driver, but this radar can also detect the motion. So that way driver drowsiness or driver alertness can be detected using this driver monitoring radar. And then there is long range radar. These are typically, as I mentioned, to avoid the complete collision. These are radars with high cost and higher resolution. Now, what do I mean by resolution of the radar? The entire car industry assumes that whatever distance I give you is within 1 centimeter of its accurate position. So if I say I am seeing an object at 10.83 meters, then I can say it is 10.83 meters plus minus 1 centimeter. That is how accurate a autonomous vehicle should be, because it's the concern of safety. Any autonomous system, if you see, we are actually making a killing machine. These machines can go out of the control. They are free to move on their own. They have their AI algorithms, and if deep learning triggers their AI algorithm, these machines can go out of control. And such kind of concept movies are already made in earlier days. These movies are called Terminators. So you might have watched them. And any autonomous system you build has a potential to become your enemy. And today in 2024, I'm saying this, but maybe in 2048, we might be fighting with these autonomous vehicles. I don't know. Now, coming to the second generation long range radar and third generation long range radar, you can see that uh, the first generation of the radars had some limitations like a bulkiness and a cost. So, in second generation, they have introduced something called as radar dome, similar to your fisheye camera's lens, to increase the range of the radar. Then you typically put a PCB board. So initially they used a separate sensor for sensing element, and then for processing a separate sensor was used. Nowadays they use a single PCB with processor and sensor. So that is the PCB circuit board for processing and power supply. And then you have your actual radar printer circuit board at the back, which is basically nothing but an antenna. So all the thing that radar do is to emit the EM waves using the antenna and to receive the EM waves using the antenna. Now in second generation, they have also changed the body casing. So initially it was plastic, and then now it is coming with a metal reinforcement with the plastic backplane. So it still uses plastic, and it still uses something called as IP68 rating, so waterproof in the second generation radar. In the third generation radar, you have same radar dome. But if you see the PCB which was placed just after the radar dome is removed, and now we first come to the body connector, and then radar PCB directly mounted onto the PCB for the power supply. So what advantage this particular method gave us is to have a single PCB board with its single daughter board. So there is no wiring required, and that reduced the size and from bulky radars to a smaller radars. So this is typically how if you open or break open any long range radar sensor, I won't recommend that, but by mistake if you open, this is how you should see the things inside. Now coming to the main sensors of the entire autonomous system, it's called LiDAR. So LiDAR basically makes the self-driving possible. Whatever you have seen in previous 10 years could be only possible because of the LiDAR. Why? Because LiDARs are cheap. The laser diodes you can get within 100 rupees in the market. So making a LiDAR based sensor, you just have to put one transmitter, one receiver. In a simplest form, you can assume a LiDAR to be a LED with LDR rotating on a servo motor. That's all it is. And definitely, it is more complex than that. Velodyne is the one of the major brands in the LiDAR, which makes the static LiDARs, and they do not rotate. So typically, nobody wants a rotating part. What will happen if rubber that is rotating the entire motor fails? The entire autonomous vehicle will fail. And that's why solid state LiDARs, which are typically costing from 50,000 onwards, and it can go up to 13 lakhs also. So these solid state LiDAR are more popular compared to a rotating LiDAR. Rotating LiDAR, no doubt, it's the smarter way of doing the things. You are using a single transmitter receiver and rotating it in all the directions. Whereas in static solid state LiDARs, you have multiple transmitter receivers placed in different directions. And that's why these particular LiDARs are not rotating and give you the better accuracy. Coming to the next sensor, I have talked about camera, then second was about the radar, and then finally we talked about LiDAR. There is one more important sensor and very, very cost sensitive, or you can get this sensor within 100 rupees. It's called ultrasonic sensor. So ultrasonic sensor is there in the car since 1990s, starting from parking sensors, which was very inexpensive solution, but still used till the day. Now, if you ask me what will be there inside your car, most probably it will be still an ultrasonic sensor, and they are ideal for providing additional sensing capabilities and for low speed. Why low speed? Because ultrasound itself, you can see that its range is very limited, typically in few centimeters. So complete obstacle avoidance, or if you just want to sense the object and stop the car, this particular sensor is very useful. And many of us might have done this kind of mini project, that autonomous vehicle with ultrasound sensor. HCSR05 is the sensor that we connect to the microcontroller. And then there is a L29 3D driver with the motors, where the motors are stopped as soon as the HCSR05 sensors receives any signal within the 75 centimeter. So typically the range of this sensor goes from 2 centimeters up to 400 centimeters. Very small but very useful sensor. Now, if you increase the range from 40 to 48 kilohertz, you can see that the reflux from the ground can also be avoided. So, if you see, not a single sensor is placed at the back, but typically a set of sensors, which we call the back sonar, which are typically four sensors connected at the back of the car. And why these multiple set of sensors are required? It's not like कि एक सेंसर पे मड लग गया तो दूसरे से तो रीडिंग आ ही जाएगा. It's basically we want a complete coverage. We don't want any blind spots or any pole. Still, if your pole is within the two sensors, I personally have seen that people do go and hit that pole. So remember, if you are trusting the parking sensors, don't park near the pole when the pole is at the back of the car. It is very, very risky because there are four sensors placed at a distance. Typically, if you see at least 3 meters wide is the total placement distance, and divided by four is the gap between the multiple ultrasonic sensors. The ground reflex can only be avoided if you keep the beam smaller, and that's why we generally go for 48 kilohertz ultrasonic sensor instead of 40 kilohertz ultrasound sensor. Now, if you see the overall, if they ask you write a short note of sensors used in autonomous systems or autonomous car, then you can start like this. You have your ultrasound monitor, then you have your imaging sensors that will have night vision camera. Then there are some visible cameras which are called VHDs, mirrorless cameras, accident recorders, stereo cameras, and basically they are dash cameras. And then there are 3D cameras for capturing the gestures, presence, or driver monitoring, which are placed inside the car, watching towards the driver. And then there are some 3D cameras placed outside the car, watching towards outside pedestrian behavior. Then the most important sensors that make this technology possible is called a LiDAR sensor. Typically, YP and RD LiDARs are available in the market. Then you have SRR, MRR, that is long range, small range, medium range radars. And then these are the millimeter wave radars. So all the frequency or the magnitude or the lambda it uses, it is in millimeter range. And that's why radar can definitely detect the objects at the longer ranges. And that's why it is still used in the flight capturing or detecting the planes, because your lidars will typically end up losing this information. Also, one important point that if there is a direct light source in front of your car, for example, your beamer or your sunlight, then your lidar might give you the faulty reading, and that's why we need to avoid using lidars for detecting jet aircraft, because it could be an enemy aircraft and it can just travel over your country and do the bombing. So that's why radar is the preferred way of using it for the planes. Now you'll ask me what will happen if there are plastic planes. Yes, this kind of risk is there for all the sensors. Ultrasound may not work if there is a loud environment. For example, अभी गणपति चल रहे तो there are loudspeakers in the range of hundreds of watts, and then your ultrasound becomes useless. So many of the times people does not get that why their parking sensor failed when they're parking. It's not the problem of your sensor, but there is a speaker nearby in the function which is playing at very high volume, and same ultrasound signals are getting received by your receiver, and that's why your sensor malfunctions. Now, one of the important sensor which are used inside the car, it's called accelerometer. Basically, IMU is the complete name of the sensor. It is inertial measurement unit. And then there are GPS and GNSS sensors which are used for monitoring the position of the car. GNSS and GPS both are navigation and global navigation systems. And then gyroscope, accelerometer, and speed pulse encoder. That is how much your car has moved exactly, actually, after pressing the accelerator. So this dead reclocking is very important concept where people do miss out. They think that car can be made just like that, but internally it must know how much actually it has traveled, how much it should have been traveled, and the acceleration gyroscope will give the information of whether it has gone through a pothole or whether anything is loose on the car. And then there are many information that you get from your GPS. Most of the times this GPS sensor is used to find out the stolen vehicle. So now your RC number is connected with your chassis number, and then chassis numbers will have a unique GPS ID, and people can track back any car which is stolen. So it is possible, but it depends on police whether they want to track and give that car detected back to the owner, or they just want to let it go. So that's why GPS sensor is very important. And if you want to stay away from the GPS sensor, you might have to steal your car and put it into an aluminum foil and get survived. It is not possible practically. So any car, at least sold after 2024, I think it should be definitely traceable, because all the cars are coming with inbuilt GPS systems. And if you are planning to purchase any car, do purchase a car with inbuilt GPS systems. They have their predefined SIM card installed inside the car. You just have to activate their service, and then that SIM card will start sending the GPS coordinate of the car. Now, coming back to the same diagram, if you see now, you have your short range radar, SRR, long range radar. So in your exam, you might get a question, compare a short range LiDAR with long range radar, or you can ask a question on dead knocking sensor compared to an ultrasound based on the price, based on the usage. And then there could be a separate short note on write a short note on 2D vision camera or ultrasound camera. Now, once we understood all the concepts of different sensors in the autonomous vehicle, now we go to the last part of the talk, which is level of autonomy. So we do have level 0 to level 5 autonomy. First thing is level 0, where warnings are momentary assistance, like your car is giving some assistance. Automatic emergency braking is in place, and blind spot clearance is also there. In level 1, steering, brake, acceleration support is given to the car. So it's like a cruise control mode. It also have lane catering, so it will have a camera or adaptive cruise control, either or. Then it will come under a level 1. In India, you can definitely get level 1 autonomy cars at the price range starting from 13 lakhs, and you can go up to 25 lakhs also. Level 2, steering, brake, acceleration support is already given to the car. Human have to drive it, but then you have automatic lane catering or adaptive cruise control. So here, basically, you have to ask human to just keep a watch on how the steering and brake is getting moved. Otherwise, it will should able to drive on its own. Level 3 onwards, actually, autonomous feature starts. So level 3 is where self-driving is activated under certain conditions. Firstly, traffic jam, and then secondly, local driverless taxis. So what is these two different conditions between level 3 and level 4? What is the exact difference? In level 3, the driver is there and it is actually monitoring. In level 4, the driverless taxi means the person on the driving seat is not there. So that is the main difference between level 3 and level 4. So in level 3, person can definitely override if he sees that your car is going to hit someone. That becomes a major threat. It will press and brake manually, and manual brakes are always override by your automated acceleration. So whenever you press a brake, actually cut off the entire circuit and it converts your car into a manual car which can be easily braked. Coming to the level 5. Now, till the date, we have reached up to level 4. There are many level 4 cars which are roaming around in the streets of California. And in India, also one or two level 4 cars were built as a prototype, not as a market product. And level 5 is same as level 4, but it will work in any conditions. Now, in level 4, their maps are pre-fed. So, entire California map is given to that car. Its location, its entire places are right. But in level 5, it is called SLAM. So, it is automatically generating the map and then driving on it, which is a level 5 autonomy. Which, like we human, if you are placed in an unknown country and then I asked you to drive, you are actually doing a simultaneous localization and mapping. So level 5 autonomy, obviously it is achieved in very small scale cars like a toy cars, but the level 5 autonomy on a real road vehicle is not seen yet. So you might take this research as your main research problem. And with that, I will end the talk and I will just show you an actual video of autonomous system and driving on the roads of the California. And I will play this video and at the same time I will stop the recording. So if you want to watch this video, I will attach it separately along with your recording. So let us see the video now. I will just stop the recording first and then I will play the video.